Friends, in this video we are going to see the topic under for the model 1, which is a tutorial class for the complex variable 1. So the problem we have seen in the last videos, which is 4 type of problem we have discussed under for the complex variable. So in this tutorial also we are going to see some of the problems, and the question is given that f of z is equal to x cube of 1 plus I minus y cube of 1 minus I by x square plus y squared if z is not equal to 0 and 0 if z is equal to 0. So the function f of z has been defined that when z is not equal to 0, you have that f of z function. If z is equal to 0, that f of z will be 0. And we have to show that f of z is satisfied the CR equation at the origin. So the question is asked to show that f of z is satisfied the CR equations at the origin. So first we will write a given f of z is equal to 0. That implies u of 0 comma 0 is equal to 0, which is equal to v of 0 comma 0. So what is that? Z is equal to 0 means the functions also will be 0. That is x comma 0 0 and v of x comma 0 x comma y, it is 0 comma 0 also will be 0. That is ux, you can find that vx, uy, vy, the differentiation of this u and v with respect to x and y also will go for 0. That implies f of z equal to 0 when z equal to 0 is an analytic at the origin, because the CR equations all the terms getting equal to 0. So you can directly tell f of z is equal to 0 when z equal to 0 is an analytic at the origin. So now f of z, you can take given f of z when z is not equal to 0. At the origin, f of z is indeterminate form. Why? Because it is getting for 0 by 0 form. So now ux, vx, uy, vy also indeterminate. Let f of z is equal to x cube minus y cube by x square plus y square. I am making this 1 plus I you can multiple and 1 minus I also you can multiple here. Then you can get the term of plus I of x cube plus y cube by x square plus y square. So now we have made it real part and imaginary part. You can get u term and v term as per f of z, u plus iv. So what is your u term? U term is x cube minus y cube by x square plus y square, and v term is x cube plus y cube by x square plus y square. So now once you have found u and v, we can go with ux. So ux is equal to limit delta x tends to 0, u of x plus delta x comma y minus u of x comma y by delta x, and u of 0 comma 0. So you can replace that x and y, the point is 0. So I will get limit delta x tends to 0. This is nothing but delta x the whole cube by delta x the whole square minus 0 by delta x. Okay, u of delta x comma y means in u of x comma y, x to be replaced by delta x, y to be replaced by 0. So I will get the term here, you will get x cube by x square, because this will go for 0, x to be replaced by delta x. That was written delta x the whole cube by delta x the whole square by delta x. So now what will happen? It will get cancelled. I will get only for delta x. So ux term will be equal to 1. And similar uy, you can find out limit delta y tends to 0, u of x comma y plus delta y minus u of x comma y by delta y. So replace u of y of 0 comma 0. I'll get limit delta y tends to 0, u of 0 comma delta y minus u of 0 comma 0 by delta y. Okay. So now what will happen? In u terms you can replace x will be 0, y will be replaced by delta y. So what I'll get a term minus of delta y the whole cube by delta y the whole square minus 0 by delta y, which is uy, which is equal to minus 1. So now you can find similar vx term. So vx is limit delta x tends to 0, v of x plus delta x comma y minus v of x comma y by delta x. So now vx of 0 comma 0 you can replace. I will get similar. What is the delta x the whole cube by delta x the whole square minus 0 by delta x, where limit delta x tends to 0, the answer will be equal to 1. Similar vy also you have to find, and you can substitute in the formula. What is that? I will get delta y the whole cube by delta y the whole square by delta y term. So what is that? It will become 1. So your vy will be equal to 1. So in this case you can tell ux is equal to vy, because ux also 1, vy also I got it 1. And what is that? Vx is equal to 1. and uy I got it minus 1. So you can tell Vx is equal to minus y. So CR equations are satisfied at the origin. Okay. So now the next question, determine the analytic function whose real part is y plus e power x cos y. So what is it given? Given as real part. So which is u is equal to y plus e power x into cos y. So what is here ux? Ux is 0 plus e power x into cos y, which is equal to e power x into cos y. Differentiation with respect to x, this will be 0. E power x remains e power x. So uy will be, I will get 1 minus of cos x will be minus sin x into e power x will be there. Okay. And you can substitute in f dash because you have to prove that as a determine an analytical function and the real part is there. So using this real part, so you can use that f dash. What is that? F dash is equal to u plus ivx as per the definition. Now what I am going to use it? I am going to use it for the, by using the CR equation is getting satisfied because the f of z is analytical function. Okay. So what is that? Vx to be replaced by minus uy. So what I will get? Ux minus I uy, which is equal to e power x into cos y minus I of 1 minus e power x into sin y. So now what will happen? You can substitute x is equal to z, y is equal to 0 because I need to integrate the term to get your f of z. Okay. So what is that? F dash is equal to, so e power z cos y will be cos 0 will be 1 and sin 0 will be 0, it will go. So you will not get any imaginary term, only the term of, what is that? E power z term I will get, isn't it? So f dash of z is equal to e power z minus, see here, you can replace here, I into 1 will be minus, I alone will come, minus into minus will be plus, e power x into sin y. So e power z into sin 0 will go 0. So what is it remain? This minus I alone will be remain it, isn't it? So I will get a term of minus I from here. So I will get only f dash of z is equal to e power z minus I. On integrating with respect to z. So we can integrate the term with respect to z. What I will get? F of z is equal to e to the power of z minus I dz plus c. Integration of e power z will be e power z. Then minus of I into integration of dz will give z plus c. Okay. So if you integrate, you will get for f of z is equal to e power z minus I z plus c to get. That is what the question is asked, to determine the analytical function where the real part has been given it. Okay. So all the type problems which has come under for your complex variables. So first type which you have seen it, which based on the only for f of z, and this is will come constructing your f of z is nothing but it will come under for your type 3 problem. Okay. So one more question, if f of z is equal to u of r comma z plus I into v of r comma u of r comma theta plus I into v of r comma theta is analytic, and given that u plus v is equal to 1 by r squared into cos 2 theta minus sin 2 theta, where r is not equal to 0. So determine the analytical function f of z. So what is the question? It is given as a mixed one. It's not in only real part or any imaginary part. It is given the combination of u plus v. So what you have to do, first we can write given u plus v, which is 1 by r squared of cos 2 theta minus sin 2 theta. Now differentiate with respect to r partially, because I'm going to replace by using the CR equation. I'm going to solve that. For that reason, I should find the differentiation with respect to r and theta. So with respect to r, I can do ur plus br in the left side, which is equal to 1 minus 1 1 by r squared will be 2 by r cube I'll get. So minus 2 by r cube of cos 2 theta minus sin 2 theta as a constant. Okay. So I can make an equation number 1, and again with respect to theta, one more time for u plus v, I'll get u theta plus v theta is equal to 1 by r squared of cos 2 theta will give minus 2 sin 2 theta, and then I have a minus of, what is it? I have a term of sin 2 theta, it will give minus 2 cos 2 theta. Make an equation number 2. Now from CR equations we have already, what is that? UR equal to 1 by r v theta and VR is equal to minus 1 by r u theta. Okay. So now from equation number 2, I'm going to replace in terms of UR and VR combination. I'm going to write it u theta. I can able to write minus r into VR. Okay, that is what written, plus v theta to be replaced by r into ur. That is written here, which is equal to minus 2. I can take it a common, minus 2 by r squared of sine 2 theta plus cos 2 theta, which is equal to, so what is that? You can write it, this equation is u or can multiple with a minus, so both the side minus will get cancelled. I'll get it ur minus vr is equal to, this r also to be taken this side, it will become r cube, then minus 2 by r cube of sine 2 theta plus cos 2 theta. I'll get, make an equation number 3. Now on solving equation number 1 and 3, because both the left side you have ur and vr combination, I can add it, vr will get cancelled, I'll get only 2ur is equal to minus 4r cube cos 2 theta, sine term will get cancelled. Ur is minus 2 by cos 2 theta, I'll get, both the side 2 will get cancelled, here I'll get only for 2. And equation number 1 I can replace, again I can take it for VR term, either you can subtract this or you can replace any one equations to get your VR. Here itself you can subtract it, it will become ur will get cancelled, you will get VR 2 by r cube into sine 2 theta. So now ur and vr we found. To construct here f of z, first I write here f dash. So f dash is equal to e power minus I theta of ur plus ivr, which is equal to e power minus I theta of minus 2 by r cube cos 2 theta plus I into 2 by r cube of sine 2 theta. So now substitute r is equal to z and theta is equal to 0. I will get f dash of z is equal to minus 2 by 2 by z cube alone I will get. Okay, the term you can integrate with respect to z. F of z is equal to minus 2 of minus 1 by 2 z square, because this z cube you can take z power minus 3 and you can apply for x power n plus 1 by n plus 1 formula. I will get minus 1 by 2 z square plus c. Therefore f of z answer is 1 by z square plus c. Okay, this is here which is when you are going to construct here f of z. Okay, so that's all. Thank you.